there, my name is Kate Weber, and I'm here to talk to you today about a John Snow Labs service that uses large language models in order to search for medical codes in a terminology server that is really a great step past the way most of us end up looking for healthcare codes today. I am a data scientist at John Snow Labs. My specialty is in data standards in healthcare and natural language processing. And so I'm just delighted to talk to you today a little bit about coding systems in general. We'll talk about a few of the most common ones, particularly in North America, and then about the challenges that go with either finding the right code or with mapping from one code vocabulary to another. And then I will show you some of the cool things our LLM-enabled terminology server can do for you. The health coding systems have arisen over and over again when people say, I don't have a clean, specific way of making sure that when I say diabetes, I mean the same thing as you when you say diabetes. And so the coding systems have arisen in multiple vocabularies over and over again as different approaches in some ways to solving the same problems. Some coding systems are principally aimed at billing so that, for example, when we have the same procedure, we always describe it with a specific billing code that our financial partners recognize. Another approach is with precision. There are many, many, many different ways to abbreviate the various values that come out of simple, basic laboratory panels. But when we use a specific code from a laboratory-oriented data or a laboratory-oriented code set, we know that we are both talking about the specific same test and that the values coming out of it mean the same thing. We use codes to translate from one literal language to another so that when the MESH medical subject headings code 5360 is there, it can translate to a user's language that is native to themselves. All of those words mean fibula in MESH. And the last thing that a lot of our coding systems do super powerfully that supports both reporting and research is that there are hierarchical relationships within many of these code systems, so that when we have the single drug ingredient of codeine, there is this hierarchy showing a spreading group of types of drugs, specific brands of drugs, specific forms and dosages of brands of drugs that all relate back up to the top so that I can say in a research question, show me all patients who are taking anything with codeine. And the RX norm vocabulary, for example, produces all of these thousands of different codes that roll up to the same idea. Some common coding systems in use include the medical subject headings, a way of making sure that we can classify papers and research in specific reproducible terms. CPT is the American Medical Association's description of different procedure coding. LOINC is focused principally on laboratory results, but also is a way of organizing documents and quizzes and questions and answers so that we can say over and over again, I've applied this instrument or this measurement and I got this response. ICD-10 is the latest, well, not the latest, the most commonly currently used version of the International Classification of Diseases, so that every time we list a diagnosis using ICD-10, we get specific. I will show you in a little bit. Sometimes we get ridiculously specific. But ICD-10 was really, it was founded in the idea of insurers wanting to understand what afflicts people and what they're paying insurance claims on. And so it gets very specific sometimes because there were very specific problems that they wanted to be able to winkle out and report on. SNOMED CT is a global, broad vocabulary that does a beautiful job of connecting relationships across, say, body parts and procedures, so that you can look at a particular concept and understand more than one axis of how it's related to things. An RX norm is a standard hierarchy of drug products. And there are others. There are many, many others. They are intended, ideally, to reduce chaos because human language is so non-specific. But because of all the chaos that exists in human language and the different needs people had when they developed each of these systems, sometimes even the coding systems cause their own level of chaos. But we want to be able to somehow say these things mean the same thing as that. We want to be able to say that hypertension and high blood pressure are synonyms of each other. You should start treating them as similar concepts that have something to do with each other. Levels of detail vary a lot. These are 5 I didn't make this up kinds of condition codes coming out of the ICD-10 vocabulary because someone wanted to know the difference between 3-wheel and 4-wheel motor vehicle accidents. Mapping between vocabularies can be super difficult, particularly when they take different approaches to levels of detail. In this particular case, ICD-10 very specifically bolts little pieces of ideas together into a single code, whereas SNOMED CT would ask you to probably write something down along the lines of, it was a motor vehicle accident and the driver was involved and it involved a fracture. And so SNOMED CT lets you stack codes together to mean something. ICD-10 has a very, 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 very specific code. The business of mapping from one vocabulary to another has its own non-matching forms of support. The Unified Medical Language System is a product of the US National Library of Medicine, and it is trying to create one central collection of concepts and then map those concepts out to every vocabulary in their list. And there's like 35 of them. And they do a great, great job. Also, the Odyssey Initiative, who have a different task, whereas UMLS is focused on kind of providing a general, here is a meta vocabulary of all the things. Odyssey, in the interests of bringing health data together from different sources, like from my Epic system and your Cerner system and your homegrown system, being able to put information together into one pile for observational research across the data sets, maps many, many different vocabularies into specific Odyssey standard concepts. So these are 2 different approaches to mapping vocabularies, and each of these organizations works nicely together, but they're kind of a parallel track of meta vocabulary management. Some of the chaos has been addressed with the FHIR standards, and FHIR brings us 2 important ideas that we can use and apply, and in fact do in the terminology server. The value set in FHIR is a collection, a subset of concepts from any vocabulary. There's not a rule about saying they have to come from the same vocabulary, or they have to mean the same thing, or even that they have to be the same kind of concept. Is it a drug or is it a condition? But value sets are a way that FHIR lets us define a collection of concepts for billing. These 5 concepts are allowed, say, for describing an appendectomy. Or for reporting, these are the concepts that we use as our roll-up concepts. And researchers will often say, okay, every patient who has one of these concepts in this value set is deemed to be positive for leukemia. And so in the grid I'm showing you here, There are a number of columns. We'll come to some of the others later, but this is a value set that shows us a collection of hypertension concepts from both ICD-10 and LOINC and SNOMED CT. And it's an example, and we'll play with it a little bit as we go along. So concept set or value sets are collections of concepts. There is no constraint on what can be in that collection. They're just there so that you can filter all of the noise out and say, I care about these. A concept map allows us to map between vocabularies. And I've taken out the gray columns there on the left because now this document can be used as the foundation of a concept map. I could say here that standard code 383410003 from SNOMED maps to my custom coding system, my in-house code system that nobody's ever heard of except me, and I call it blood pressure, and I also call it hypertension, and this is my code for it. So you can build with FHIR a custom concept map that lets you take whatever you want to do, whether it's a custom in-house vocabulary or your specific ideas of how you want to go from, say, LOINC to SNOMED CT, and you can map those yourself, which is great. So I want to show you our terminology server. Typically, when you are looking for different code lookup tools, they are very focused on specific string searches. And so you find yourself trying to say tuberculo asterisk or other attempts to be able to winkle out the specific strings in the names of the codes so that you can start to narrow down the actual codes. Our terminology server that I'm going to show you uses a large language model in order to be able to say the semantic meaning, the core understanding between this word in this search and the terms in our vocabulary match. So I can, and I'll show you, type in high blood pressure and get back hypertension. This really helps us when we're dealing with layman's terms or when we're dealing with spelling errors or when we are dealing with different cultural words for things. I'm looking forward to showing you that. The terminology server has 24 common vocabularies just loaded on board that we keep up to date. It understands when something it's presenting to you is an OMOP standard concept, which really matters if you are working on building mappings in the OMOP world. We do mapping between vocabularies. We can have custom value sets, and it has both a graphic interface and API-based interaction. So let me show you our server. You are looking at the very beginning of the terminology server's interface. And I'm going to copy and paste my favorite unpronounceable word. And you can see it immediately goes out and looks up cholecystectomy, which most of us think of as a gallbladder removal surgery. And it is bringing back different domains. It brings back these LOINC values, and it says they are measurements. It brings back a SNOMED CT procedure codes. It shows an observation of a cholecystectomy planned. And it goes on through various matches. It's ordering them in terms of how reliable it thought the response was. And I also want to point out that it is not specific to English. We have a Chinese LOINC data set loaded, which means that this string here maps to the Google Translate capability, gallbladder removal surgery. And it can be semantic matching or string matching. I could botch the spelling here, and it will still find those things. But if I tell it I want an exact text search, it won't find anything. By default, we send a string out to the terminology server, and if it finds an exact text match, it brings information back right away. And then if it cannot, it goes and it looks for semantic matching. By default, we have it do both. So, we've got the layman's term gallbladder removal. It can get even more generic than that. Let's try this. This is how you know I started in the morning. So it is able to go and find semantic matches that match the different chunks, the different ideas that we have. Here are the code systems that are included. And so I can, if I want, filter on SNOMED CT, and it will only bring back SNOMED things that probably are coffee headaches. Let's look at something a little more serious. So there's the removal of an appendix. And one of the things I can do here is take advantage of the baked-in concept maps. So for SNOMED CT, I can say, go find me the UMLS codes that are the equivalent of these things. So now I'm mapping back to the meta vocabulary, and I'm able to get the specific UMLS concept code, or CUI, that matches these particular things. And so we maintain mappings for each of our vocabularies. And when I select a specific vocabulary, then you can see the concept maps that we are carrying matching concepts along with. So let's find another one. Let's find high blood pressure. Here's high blood pressure, hypertensive disorder, high blood pressure. ICD-10 even helps us out by giving us some of the abbreviations for it, which is cool. But that's a lot of different high blood pressures. And it might be that I want to filter my view. Well, let me turn off the concept map. It may be that I want to filter my view so that I'm showing hypertension in the information that was in that little spreadsheet. So here's my value set for hypertension with a match to that specific SNOMED code. There we are. There's 388-41003. And here we are getting this information fed back because it matches in the value set. I'm also able, if I want, to just filter my output by value set. And in fact, only one of this particular return of results shows us that. I am able to, if I want, update my value set. I can upload a new one, and I can say I'm going to go to the existing hypertension value set, and I can get an updated hypertension value set. And it will bring that on and allow me to extend my search results, because now I have the different high blood pressure codes that match in my new version controlled value set. And anytime I have results, I can download those results and they will head off to a CSV file so that you can take this information and continue to manipulate a report on it. Now, I said that we also have an API service, which is just fabulous, because most of the time when we want to work with these kinds of tools, we're working at a volume that's more than just, poking around in a GUI and saying, oh, that's cool. So the API is mostly the real nuts and bolts of it is an endpoint that helps us search. And we can filter on vocabulary ID. We can control how many come back. We can filter by value sets. And here, I'll show you how it looks in action. I'm going to load up a simple search helper that lets me send the request off to the API endpoint with a collection of filters if we want it. So You can put as many different terms in that sample chunk as you want to send, but let's just do a simple hypertension search. I am saying, look for hypertension and bring me back the top response. There it is. It is also feeding you more information than you necessarily get to the GUI by showing you, among other things, a confidence score on the search and whether it was involved in the value set. And you get detailed information about whether it was a standard concept and what vocabulary it came from. And so let's look at high blood pressure. And it is bringing back hypertension codes. And I'm going to say, in fact, I only want the ICD-10 vocabulary, but I want the top 3. And it is now bringing back 3 ICD-10 codes, along with our confidence scores. And again, this meta information about where it came from so that you can use it in your reporting and processing. And I can, if I want, bring my value set into the question. And the 3 matching codes also match with this value set record here. So I think most of the time when you're wanting to work with this information, you'll be coming at it through the API. And I think that is probably your most effective way to get a rich collection of information about mapping and about how to use your value sets and about the detailed information for each of these concepts coming back from the terminology server based on these string searches with semantic information mapping. So to wrap up, we've got the ability to search a whole swack of vocabularies and filter and sort and export the information you get back. And instead of being reliant on hard-coded string searching, we use an LLM in order to help you get concepts that mean the same thing as what you are asking for. We will continually update the vocabularies and the mappings between them as part of the delivery of this service. If you want, you can upload your own custom value sets to help constrain searches or show where the search results map. We have designed this so that you can deploy it in your own environment so that you are not making calls outside of your security perimeter and you're able to work entirely within your organization's infrastructure. The terminology server is available now if you want to start working with it. And I also want to put a quick plug for the John Snow Labs Patient Journeys product, which is taking any collection of input information, whether it's from your EHR or from FHIR messaging or from piles of clinical notes, and sorting and merging this information into the OMOP standard common data model so that we can help you use LLMs to properly search and understand the longitudinal part of your patient story without having to stitch together many, many different data sets. And it is absolutely, the terminology server is absolutely critical part of this tool. So that wraps up this conversation. I'm looking forward to having a chat with you about questions you've got. We can go deeper into anything you want to work with. We can experiment more, but I really appreciate your time and attention today. Thank you.